In this video, I'm going to address a fairly common question that we get, which is around filtering traffic going to private endpoints when using Azure Private Link. Does it make sense? And if I do want to do it, how can I do it now and how can I do it in the future? So let's look at this diagram here. I've got my on-premises location here on the left-hand side, which is express route connected to this lab environment, which is a purple lab environment based on Azure Virtual WAN, and a green lab environment based on regular customer hub spoke VNets. And in the spoke VNets, beyond the hubs, I've got both private endpoints and I've got virtual machines. So the question is, when I send traffic from on-prem, it comes in via express route, can I filter that traffic using a firewall, or is there another way of doing it? The first question that I would always ask in this situation is, why do we think there's a need to do that? If we think about the default behavior without private link, when the service is exposed on the internet, you generally are trusting the service's security controls to do that. So similarly with private link, I think it's good to zoom out and go, just because a service or user in my network, whether that be in Azure or on-prem, has actual layer 3 network reachability to my private endpoints, is that actually a concern? Because that will only give you the network access. For example, if you're accessing storage account, you'll still need the relevant credentials. If you're accessing Azure SQL Server, you will still need the relevant credentials. However, despite saying that, there are still situations, customers, industries where this is something you want to do. And in this video, I'll address the technical options for doing that and explain how it works today, some of the options we have coming down the track. So in this topology here, let's think about the default behavior. Let's think about the traffic coming in from on-prem and going into a virtual WAN hub where I've got an Azure firewall, so it's a secured virtual hub. Let's think about a situation where the Azure firewall is in its default configuration with no rules on it, so it's denying everything. If you test this scenario, which I'll show you in a second, what you'll find is traffic is blocked as you expect going to the virtual machine, but traffic is actually allowed still going to the private endpoint. And this can seem slightly puzzling at first, especially because private endpoints manifest themselves in the portal as NICs, like virtual machines do, but the behavior of these private endpoint NICs today on the platform is not the same as other NICs. And we'll explain why. Similarly, in this regular hub spoke network down the bottom here, we're taking in traffic via express route, and then before that traffic can enter the spoke, we're using UDRs on the gateway subnet to send traffic to Azure Firewall, which then goes into the spoke. And then on the way back, the spoke's got UDRs that say, before you go to on-prem, go to Azure Firewall. So we've inserted that Azure Firewall in the flow. And similarly, on that Azure Firewall, we've got no policy, so it's denying everything by default. And what you see is the default behavior is we block traffic going to the VM, as you would expect. But the fact that we allow traffic going to a private endpoint can seem counterintuitive. So let's look at a client that I've got on-prem. This is a client in my 192 range. What we can see here is on the right-hand side, these pings are running, going to the actual virtual machines in the spokes. So you can see that traffic's being blocked. This middle box here is showing that my DNS resolution is correctly integrated into Azure DNS private zones. So when I try and resolve my storage account, I get back the private endpoint IP. When I try and resolve my SQL server, I get back the private endpoint address. So you would expect perhaps that traffic will be blocked, but as we see here, I can access a text document in a container inside of the blob storage account, and I can also connect to my SQL server via that private endpoint. So this shows that, flipping back to the diagram, despite us having the required routing in place, when we first look at it, the traffic going to the private endpoints has been allowed. The reason why that's happening is, by default, what happens today on the platform is there's a special route inserted for these private endpoints. So we can actually take a look at that. So I'm looking at the effective route table here of a virtual machine in the hub. And here we see 10.2.1.5. That's my private endpoint in the spoke. You can see here how we're learning that via a /32 with this special next hop type of interface endpoint. And the fact that we learn the private endpoints as /32s, that means we're effectively circumnavigating the routing intent that we've tried to apply. So rather than following these purple lines, the traffic going to that private endpoint, you can consider it as the traffic is bypassing the firewall. Similarly, the intent that we get when we instantiate an Azure firewall in virtual WAN, that you can think of that intent is also being bypassed when traffic comes into the virtual WAN hub due to that /32 route leakage. So let's think about our options to change this default behavior now that we've understood it and why it's happening. And I'll talk about broadly two options for resolving this behavior. Before exploring the first option to achieve the filtering that we want, it is worth highlighting that whilst I'm focusing here on the hybrid scenarios from on-prem into Azure, overriding this default behavior of private endpoints today could be equally as applicable between two directly peered VNets or in the same VNet in Azure. So the same methodologies that I'm going to present here will be applicable for sort of most use cases when you're filtering traffic to private endpoints. Okay, so the first option we have is around overriding the routing to those /32s. So remember I said the default behavior is those /32s leak out of the spokes into the hubs and causes this bypass of the firewall that we're seeing. So one way of getting around that is to change the routing so that we force that specific /32 route to the firewall. So I've made the following changes. On the gateway subnet, within the green environment, I've put a /32 route, which represents my private endpoint, and forced that towards Azure Firewall. You can see that here. And then within my virtual WAN environment, I can achieve the same outcome by editing the private traffic prefixes within Azure Firewall Manager, which is located here. That's the IP address of my private endpoint. And I'll leave these links in the comments below. These are guides for doing the process that I'm describing here. One for Azure Virtual WAN, and two within a regular customer managed hub spoke environment. So now that we've made those changes, we would expect that traffic going to our private endpoints and therefore our PaaS service is now blocked by our default deny policy on the firewall. So let's confirm that behavior. We can see on the right hand side, pings going to the VMs are still timing out. If I refresh my access to my blob, my Azure Storage blob container, that is now failing. Let's also confirm that our SQL access is now blocked. Okay, so as expected, the changes that we've made to the routing are now causing the Azure firewalls in both the purple and the green labs to be put in the traffic path. So the next question you might ask is, now that they're in the data path, how do I open traffic going to the private endpoint? And the recommended way of doing this is by using application rules in Azure Firewall. And the primary reason for that is when traffic comes into Azure Firewall and then leaves by virtue of a application rule, Azure Firewall will source map the traffic before it leaves, and that's got some implications under the covers on the platform in terms of how Private Link works. In a similar fashion, if this was a network virtual appliance here, then the recommendation would be to configure a SNAT policy for rules used for traffic destined to private endpoints. So let's go ahead and insert the required rules to get our private endpoints working again. Firstly, on our virtual WAN environment, which is managed via Azure Firewall Manager, let's look at the firewall policy. I'm going to set this rule here to allow. This is a rule that allows the required access to my storage account. And then on my traditional Azure Firewall, which is being managed autonomously here with the classic rule set, I will also modify the rule, which I'm using to allow SQL access to my SQL server. I'm going to allow that traffic. Okay, our rules have finished updating. Let's go back to our clients. VM access is still being blocked. Let's retry our storage access. It's now working, being allowed by our application rule. Same thing for Azure SQL. That's also been allowed by our application rule. So that is the end of option 1. Let's talk a little bit about the second option. So to do that, I've reset the lab back to baseline. So I've removed those private traffic prefixes from the vWAN hub. I've removed the /32 route from the gateway subnet. So we're back in the state where the private endpoints are bypassing the filtering, and we're looking for a way to correct that. I've also removed those application rules, so we're back to the state of a firewall that's denying everything. One thing I'd like to call out regarding the application rules, and this is applicable to both scenarios, is notice how my Azure Firewall is integrated with my custom DNS in both environments. And that's important because that means that when the Azure Firewall performs a lookup for the FQDN as part of the application rule processing, it will get back the same private endpoint IP as my client. And therefore, when the application rule gets instantiated in the logic of the firewall, it's allowing traffic to the right destination. Otherwise, the firewall might get back a public IP, and then you've got this this mismatch between the DNS response returned to your client and the DNS response your firewall gets. Okay, so let's just make sure that we're back to the default behavior. So VM's still being blocked, and our PaaS services are working. And remember, they're now working by virtue of the firewalls being bypassed. Okay, there's currently a public preview of a feature enhancement that's coming to the platform later this year for UDR support on Private Link. And that's got certain region restrictions. You need to register your subscription for the feature. So I've done that in mine. And then this lets you modify a setting, a parameter at a subnet level. And this is explained in some of the documentation here. And the setting that we modify is this one here, the private network, private endpoint network policies. Now, when you deploy a private endpoint via the portal, this setting gets set to disabled on the subnet. And in a roundabout way, this is what causes those /32 routes to leak out. What you can do when you've signed up to this preview, you can modify this parameter on the subnet within which your private endpoints are deployed to effectively stop those /32 routes leaking out. So let's first of all check the status of the subnet in its default form. Okay, this is our subnet that's got our private endpoint in. And if we scroll down, we can see that the private endpoint network policies is set to disabled. And that looks different to other subnets that have the default setting of enabled. And once we've signed up to this preview, we can modify this parameter, and we can then observe the behavior change. So let's first of all modify it for our virtual WAN based environment. You see there I'm passing the parameter to set it to enabled. And then let's modify it for our regular customer managed hub and spoke environment. One way to verify the impact of that change is to look into the routing table of one of the virtual machines in the peered VNet. So here I'm going to look inside of a route table attached to a VM here. Remember, I've just made the change on this subnet, so the /32 routes are no longer leaking out. And we can see that where before we had these 10 to 1.5/32 routes for our private endpoints, we still have them, but now they are reflected as being invalid. What that means is, rather than having to do the overriding of the /32 routes at the gateway subnet level or the virtual WAN level, we've effectively stopped them being advertised from the spoke VNets by virtue of this preview feature. So let's confirm that our configuration changes have had an effect on our client. So we can see that the Azure storage access is now blocked by the firewall. And we can also see that the Azure SQL access is also blocked. So to make sure that we rubber stamp this, let's go ahead and re-enable our application rules. Okay, I've re-enabled the rules. Let's retry our connections. SQL's working, so that's now being allowed by our firewall in our customer managed VNet by virtue of that application rule. And in the same way, our Azure storage access is now working by virtue of the Azure firewall application rule. And just to reconfirm, this is now happening not because we've added /32 routes on the hub side, it's because we've stopped leaking those /32 routes out from the spokes thanks to this preview feature. There is actually an option 3 here, which I'd like to highlight, and that is around NSGs or network security groups. So I've simplified the topology now. So I've removed my Azure firewall from my virtual WAN hub. This is just a regular vWAN hub now. In the bottom diagram, I've removed my Azure firewall, and on the spoke subnets, I've inserted a NSG, and this NSG is at the subnet level, so it's blocking all inbound access from on-prem to anything in that subnet. So we can see here, I've got a rule with a high priority that is blocking anything from my on-prem range. I've got that applied to both subnets. So in a similar way that we would expect the Azure firewall to be blocking access to the VM and the private endpoint, what you'll find is by default, NSGs, inbound NSGs, of course get applied to virtual machines, but by default on the platform, as we said, the NICs of private endpoints don't behave like regular NICs. So the NSGs, when they get applied inbound in the data plane in Azure, the default behavior on the platform today is that the NSG won't apply to the private endpoint. So now that we've reset a topology, put these NSGs in place, let's just confirm that baseline behavior. So back on our client here, the virtual machines are still timing out. And let's refresh our access to the PaaS services. And the expectation here would be that this traffic is now working. So our storage access is still working. And our SQL access is still working. So despite the subnets having NSGs inbound blocking all access, the private endpoint is effectively circumnavigating that due to the default behavior of the platform today. Now that preview that we saw earlier around opting in for UDR support with private endpoint, we can also use that preview, the same one we opted in for, and using the same methodology to opt into NSGs being effective for private endpoints. So once again, I'm going to take the code that I used, the PowerShell commands that I used to enable this parameter, private endpoint network policies, on my subnets within which my VMs and private endpoints reside. Now bear in mind, this is the only change that I'm making. I haven't changed any routing. There's no Azure firewalls in play here. Let's do this on both environments. Let's confirm that setting's taken. So all of my subnets have this parameter set to enabled now, including the one that has got my private endpoint in. So I'm opted into the preview. I've made those changes. And we would expect now that the NSGs should be effective for the private endpoint NICs as well as the VMs. So when I check it on the client now, the expected behavior now is that access to the SaaS services should be blocked. So first of all, let's check our SQL access going through our regular customer managed hub environment. We can see that's now timing out. And then let's try access to our Azure storage account, which is also timing out. Just to replay that back, the inbound NSG that we had applied to the subnet, which by default is of course effective on virtual machine NICs, is now effective on that private endpoint NIC once I've enabled and opted into that preview feature. Okay, let's wrap up. So we talked about the filtering of traffic going to private endpoints. We talked about how today the platform behaves in a certain way, and we presented the options that we have to push that traffic via an NVA or filter it with NSGs. First thing I recommended was to double click on your decision to filter the traffic. As we said, the PaaS services themselves have security policies that you can use on them, and that may be sufficient for your business. If you do decide you want to go down this route of using the network level protection between your users and machines and the private endpoints, we broke that down into 3 high-level options. So the first option we talked about was we alter the platform's routing behavior to override the /32 routes that private endpoints currently leak out. And we showed how to do that with a virtual WAN environment, and we showed how to do that with a regular customer managed hub-spoke environment. Ultimately, by doing that, you get the traffic to an Azure firewall or an NVA, where we said, make sure you SNAT with application rules or with your NVA's policy. Don't forget about synchronizing your DNS between your filtering appliance and your client. And if we do all of that, the traffic will eventually make its way to the private endpoint based on your security intent. Another way of achieving the same behavior is to tackle the problem from the private link side. You can get an early access preview of that behavior by opting into this public preview. And the first public preview we showed was the UDR support for private endpoints. And we discussed how by enabling that parameter on the subnet within which your private endpoints are contained, you stop those 32 routes leaking out and ultimately achieve the same thing. The traffic will get to your Azure firewall or your MVA, and the other steps equally apply. The third approach we talked about was to go down the NSG or Network Security Group path. And for that one, we simplified our environment, we removed our Azure firewalls, and we showed how by opting into the private link network policies preview and enabling that on the subnets within which your private endpoints are located, you can change the current behavior of the platform, which ignores NSGs inbound on private endpoint NICs, to make those effective and ultimately use them as your point of enforcement. And therefore, if your NSG allows, your traffic makes it to the private endpoint and then onwards to the PaaS service. So I hope you found that useful. I hope you now better understand the current behavior of the platform, the future behavior of the platform, and the options that you've got today and in the future.